Okay, so we're going to do section 2.1, which is a pretty easy section all in all. It's just the basics of functions, and it takes things from a pretty basic standpoint. So to start with, we just need to understand the difference between a relation and a function, or what domain and range is. So a relation is any set of ordered pairs. There are no rules. The domain is the set of first values or x values or inputs, and the range is the second values of the ordered pair or the y values or the outputs. So for our first example, they want the domain and range of this relation. So your domain, I'm using a writing tablet because I'm at home and it's not the best. My handwriting's not the best anyway on it, so sorry. I apologize. Okay, so domain, we want 0, 10, 20, 30, and 36. We put these little fancy brackets just to say that it's a set. These guys right here, that's what they're supposed to look like. And then the range is just the second number. So the key is that you don't have to repeat yourself, and in theory, you should put them in order. But there is no actual rule that says that that has to happen. That was a comma. That's supposed to be 0.2. And what's left? 17.4. I think I got them all. And that last little thing right there was supposed to be a bracket. I'm telling you, this is going to be a struggle. Okay. Okay, so a function is a special kind of relation where every value in the domain corresponds to one value in the range. So it can only have one input, one input for each output, one output for each input. So basically, you can repeat y values, but you cannot repeat x values. So when you're looking at a set of numbers or a set of ordered pairs, you're really just inspecting the x's, those input values. Those cannot repeat unless they have the same output. So since 5 has 2 different outputs, this is not a function. Here we have all of those inputs just used one time, so this is a function. All right, so functions are generally given to us in equations, not ordered pairs. So we have to be able to handle that aspect also. So remember, with an equation, your independent variable is your x and your dependent variable is your y. So independent goes with x, that's your inputs, that's your domain. Dependent is your y, that's your output, that's your range. So in this equation, x is going to represent the number of years worked for a company, and y is the number of sick days that you earn. Because the number of sick days depends on how many years you've worked, then x, the number of sick days, is y. What does this say? Yes, y. Sorry. Y is the number of sick days. I had them backwards in my head. And so y is your dependent variable. I was starting another sentence and then I finished the wrong one. Sorry. All right, so we can have equations that are not functions. So if more than one y value is found for an x, then it's not a function. And that's not going to happen with things that you're used to seeing, but it can happen with some situations, which we'll discuss. But if you think about, like, if we just had a random, if I asked the computer in the office to spit out kids with a particular birthday, that would not be a function because there could be more than one kid that comes out of the computer when I enter a birth date, because there's more than one person born on any given day. All right, so if we're looking at an equation and we want to know if it's a function, there's a couple of ways. So basically, we are just going to ignore all of this for a minute. We're just looking right here. We're just going to think about what we know it looks like. That's honestly the easiest way because you should know what most functions they give you look like. So this plane x, plane y should be a line, and we know lines are functions. So this is a function. This one, x squared plus y squared equals a number, is a circle, and circles are not functions. You can get y by itself and put it in your calculator and look at the picture. You can know what things are when you look at them. Like, you know, x squared makes a U shape. You know, absolute value bars make a V shape. You kind of should know a general idea what things look like when you look at the equation. So that's really what we're going to use here. Another option is think about lots of input values. If I put things in for x, is there more than one option for y? What it basically boils down to is I can do whatever I want to the x. But if I start doing things to the y, where I can get two different answers, then that's where the problem is going to lie. So the fact that y is squared is what causes the issue here. If we had absolute value around a y, or we had a y to any other even power, those are the two big things to look for that are going to make it not a function. Again, it doesn't matter what happens to the x. It's always going to be a function. It's if we start messing with the y on the equation where we can cause things to not be a function. All right, so the rest of what's on the screen is just telling you that we tend to name functions with letters. We try to only use F, G, and H, capital or lowercase. F is the most common, but you can use any letter. So if they use something else, it's okay. F of x is function notation. F of x and y are basically the same thing. Make sure that you understand it's not f times x, it's f of x. And it is basically the same thing as y. All right, so to be able to evaluate a function, can you plug in a value? So I want f of -5. That just means wherever there's an x, I put in a -5. This lesson is, in my opinion, kind of a hodgepodge of random information. Can you work with functions? Can you recognize functions? Those kinds of things. All right, so this is 25 plus 10 plus 7. So 35 plus 7, so 42. So f of a -5. I cannot make that look like a 5. We'll try again. There it goes. F of -5 is 42. That means you have the ordered pair -5, 42. All right, if I want to plug in something uglier, that's an option. It takes a little bit more work. X plus 4, getting a little ahead of myself, that's a plus sign, then a 4, squared minus 2 times x plus 4 plus 7. All right, so x plus 4 squared, you're going to get x squared. You'll get a 4x and a 4x, so 8x, and then a 16. Distribute this -2, so that's -2x minus 8. And then your plus 7. All right, combining like terms, you get x squared. What is that? Plus 6x plus 15. All right, and then here, if I plug in a -x, then we have a negative times a negative is a positive, so this is really just x squared. Negative times a negative is a positive, so this is plus 2x. And then plus 7. All right, so evaluating whether it's a simple number or an expression all kind of works the same. Plug it in for x and work it out. This was just showing like what was happening. Honestly, 42 is all I need as an answer. Okay, so linear functions. We know that they're in this form, y equals mx plus b. We know that they make a line. Right now, though, we're just graphing with a table because we haven't learned to graph a line yet in this book. So what they're wanting you to do is to say that if I make a table, and I'm just going to make one table and put all of it in there. They want us to go from -2 to 2. And it says integer, so that means I don't have to do decimals. All right, so if I do f of x, that's 2 times -2, so -4. And then g of x is just subtract 3 from that. So you see how this is 2x and then a -3. So it would be -7. So 2 times -1 is -2, minus 3 is -5. 2 times 0 is 0, minus 3 is -3. 2 times 1 is 2, minus 3 is -1. 2 times 2 is 4, minus 3 is +1. So then it says graph those on the same coordinate plane. I know I have those drawing tools down there, but they don't work because this PowerPoint is like pictures of or this flip chart's pictures of another thing that I got from a teacher at Bipsy, and you can't draw on a picture with the drawing tools. It's very annoying. Okay, so for f of x, we have a point at -2, -4. We have a point at, it's so aggravating when that happens, -2, -4. No, really, just that. Okay, -1, -2. I can't hold it too long, so drawing a picture is really difficult. 0, 0, and I'm not on an actual coordinate plane, so it's going to look a hot mess. 1, 2, and 2, 4, and that should make a line. And we're going to pretend like it's straight, and then I went through my dots. All right, so for this one, it's all of the same points, but shifted down 3 units. Let's see if I can just make, like, literally just make dots. If I can make that work. Should have a point at 2, 1. There's the next one. All right, so then we get this line. And you should notice that they're parallel. All right, so you're going to be asked to graph some lines. Hopefully you can handle that. Just make a t-table, or if you can remember how to graph with slope and line or something, I'm okay with that too. Just give me some lines. All right. The other thing that we need to know about a function is a vertical line test. So it may ask you to graph some things other than lines too. Sorry, I just thought about that. The point of what we did on this last slide is really that you understand how an input-output works. Like I can plug numbers in for X and I get out Y values and how to graph those. So they may give you something other than a line to graph just by making a t-table. All right, so vertical line test is a way to test to see if you have a function looking at the graph. So remember, the vertical line test is if I take my pencil and I run it across the graph, do I cross it more than one place vertically? Because if I have 2 points that line up vertically, that means this X value has 2 different Y values. So it doesn't pass the vertical line test, meaning it doesn't pass the rule for a function. So this is not a function. This is a function. This is a function. This is not a function because you have points lining up vertically. This is not a function because you have points lining up vertically. This is a function because even though this is starting to go almost straight up, it's technically not. And then same thing here, this is a function. All right, so next, remember that when you're looking at a graph, closed dots are values that are included and that the graph won't go past those. An open dot is a value that's not included. So the graph goes up to that point and does not include it, and it also does not go past that point. An arrow indicates that your graph is going to go through that point and keep going. All right, so set builder versus interval notation. Interval notation is the one with the brackets. Set builder is the fancy business like this. So remember that this says from -3 to -2, including both of those numbers. That's exactly what this says. And we just put the extra step that says x such that that is true. Okay, so remember that parentheses are for open circles, not included points. Brackets or for closed circles, included points. Just like the line underneath is for a closed circle. If there's no line underneath that inequality symbol, it's for an open circle. All right, so we want domain and range looking at a picture. So for this one, the domain. Domain is the x's, so left to right. So this graph goes from -2 to +1. An open circle, so -2 to +1 with a bracket. I do not need set builder notation from you. You can just give it to me in interval notation. All right, the range is bottom to top. So we go from -1 to +2. -1 has a closed circle, so bracket. +2 is an open circle, so parenthesis. All right, next problem. The domain. We go from -2 to +1 again. Closed at -2, open at 1. -2 to 1. And then range is bottom to top. And remember that you don't have to have your bottom or top be an actual circle. So the bottom of this is at 1, where that low point occurs, and the top is at 5. There's no circle here, so there's a point there. So 1 gets a bracket, and so does 5. All right, so this one, for the domain, we're going to go -2 to 1, and a bracket on both ends. And range is going to go from 0 to 3, and a bracket on both ends. All right, so for this one, for your domain, we cover every number from -3 up to 0, but not including 0. So this little open circle, that closed circle uses that number. So we go everywhere from -3 up to 0, but don't include 0. For the range, though, we are only going to use the numbers -3, -2, and -1. So we're going to write that as a list. You can't write it as interval notation because you can't say go from this number to this number. All right, so this one, our domain goes -infinity because it points to the left. Infinities always get a parenthesis because they're not an actual point. And it goes up to 4, which has a closed circle. The range, we have a bottom of 0. And it's going to go up forever, very slowly, but forever, so to +infinity. Okay, so zeros of a function are the x values where the function is 0. So these are also known as x-intercepts. Y-intercepts is where a graph crosses the y-axis. It's what happens if x is 0. So for zeros of the function, that's when the function is equal to 0 or the y value is 0. So we're on the x-axis. So a y-intercept is where the x value is 0. You're touching the y-axis. A function can have more than one x-intercept, but at most one y-intercept. So I can cross this axis all I want, and I'm still going to be considered a function. But as soon as I hit the y-axis in two places, I'm not a function anymore because I don't pass the vertical line test. Okay, so you're going to be asked to give lots of information from a graph. So let's practice and see what we got. So domain for this one is going to be -3 to 3, both of which have a bracket because they're closed circles. Range is going to be, it looks like -2 to 2. All right, so x-intercepts, where does it cross the x-axis? That's going to be -3, 0, and 3. Y-intercepts, you can give those as ordered pairs or just list the numbers. It doesn't really matter to me. The y-intercept is only at 0. And then the indicated value, can you tell me what f of -3 is? Well, if you find -3, the function value there is 0. If I ask you for f of -1, then you would tell me that it's about -1.5. Okay. All right, so looking at this next one, let's see, domain. We go -infinity. And this is a weird one because it stops at 0 and then hops over and picks back up at 1 and goes forever. So this little union symbol comes in handy. For the range, we also start -infinity because it points down, and it goes up to 1, and then it jumps up to 2, and it stays at 2. So we can actually put this in brackets because it's just going to be 2 because it's flat right there. All right, so let's see if I can scoot down just a little bit. The y-intercept here is 1. The x-intercept here is, I don't know, we want to call that like -0.75. And then f of 0 is 1. If I asked you for f of 1, you would have to tell me undefined. If I asked you for f of 2, you would tell me 2. If I ask you for f of -2, you would tell me that it's about at -2. So the ones on your assignment, I don't think are that like where you have to guess a lot. There's one on your test where you are going to kind of have to eyeball some things, and there's a lot of leeway given. As long as you're close, you're going to be okay. All right, so that's everything for that lesson. If you're fuzzy about anything, let me know. When you're working on your homework, if you have questions, please email me and let me know.